10 videos ago, we made a claim. Real text does not come in sentences. Real text comes in documents. And documents behave differently. 9 videos later, we've walked through every layer of that claim. Cohesion, coreference, topic segments, textual entailment, time, summarization, generation, speech in, speech out, vocabulary. That's lecture 8, and this video is the recap. Then we set up lecture 9, the one where NLP finally meets the real world. And then, the bridge. Because lecture 9 is where all this machinery finally ships. Machine translation, information retrieval, question answering, sentiment at scale, chatbots, the applications lecture, what real customers actually pay for, and where every one of the tasks from late shows up in production. Video 9 ended with term extraction, TF-IDF, C-value, RAKE. Classical methods that still run in production because they never hallucinate. And that's the through line for the whole lecture. Late is the lecture where NLP stops pretending each sentence is an island. Documents are structured. Speech has its own structure. Fields have their own private vocabularies. Every task in late is one specific layer of that structure. Today's puzzle. If late covered 9 separate layers of structure, how do they fit together inside a real product? And the answer is L9 shows you. This video is the connective tissue. First, we recap all 9 layers cleanly. Then we set up what's coming. Machine translation uses coreference. Information retrieval uses term extraction. Question answering uses entailment. Sentiment at scale uses summarization. Chatbots use every single one of them. Today's 3 beats. First, recap VON through V5. The document layer. Sentences to documents, segmentation, entailment, temporal, summarization. Second, recap V6 through V9, generation, speech, vocabulary, NLG, ASR, TTS, term extraction. Third, the lecture 9 preview, the applications lecture, where all this machinery finally meets the messy real world. Beat 1, VON through V5, video 1, from sentences to documents. Cohesion versus coherence. Halliday and Hasan, 1976. The 5 kinds of cohesion. Coreference resolution. The Winograd schema, and the way modern LLMs pushed Coref from 60% accuracy to over 90%, not by solving the task, but by reading the whole document at once. Video 2. Text segmentation. Where does one topic end and the next begin? TextTiling from Hearst 1997 measured lexical cohesion in sliding windows. C99 used a similarity matrix. Neural topic shift detectors learned it end to end. All the same underlying question, mark the boundary between 2 subjects. Video 3. Textual entailment. Does sentence X imply sentence Y? SNLI dataset. Bowman and collaborators 2015. NLI became a probe for what LLMs actually understand. Video 4. Temporal processing. Dates, times, yesterday, soon, about a week ago. TimeML annotation standard. Jurafsky and collaborators 2003. SUTime from Stanford. Temporal relations between events. The whole hidden layer that makes a news article coherent about when things happened. Video 5. Text summarization. Extractive with TextRank, abstractive with pointer generator networks, then BART from Lewis and collaborators 2020. And now every LLM can summarize on demand, which changed the whole task. B2. V6 through V9, video 6. Natural language generation, the classical pipeline. Content selection, then planning, then surface realization. Then template-driven Mad Libs from the 1990s, then neural NLG with Seq2OSeq, then LLMs, which collapsed the pipeline into prompt the model, same underlying task, very different engineering. Video 7. Automatic speech recognition, from raw waveform to transcript, MFCC features, HMM-GMM, deep acoustic models, then Web2Vec 2.0, then Whisper from Radford and collaborators 2022. One model, most languages, most acoustics, transcription that just works. Video 8. Text-to-speech. The mirror direction, concatenative unit selection from Hunt and Black 1996, parametric HMM, TTS Tacotron 2017 that went end-to-end, WaveNet from Van den Oord and collaborators 2016 that generated raw audio samples, Hi-Fi GAN and neural vocoders made it fast, VALE and Style TTS 2 do zero-shot cloning from 3 seconds. Video 9. Term extraction, TF-IDF from Spark Jones 1972. C-value from Francie and Aniadu 2000 that fixed the nested term bug. RAKE from Rose and collaborators 2010 that runs on a single document with no reference corpus. Real vocabularies like SNOMED and MESH were seeded by pipelines like these. LLM prompting is now competitive but hallucinates. Regulated production pipelines still run classical first, LLM on top. That closes the late tour. Beat 3. Lecture 9 Preview. The applications lecture, where the layers of late finally get woven into products. Machine translation, statistical MT with phrase tables, then neural MT with sec2IOCQ, then transformer MT, then LLMs that translate as a byproduct, coverage of 100+ languages, and the tension of translating between two languages that have unequal amounts of training data. Information retrieval, the whole given a query, find the relevant documents problem. BM25, dense retrieval, retrieval augmented generation. Question answering, reading a passage, finding the answer, squad dataset, then open domain QA, then RAG. Sentiment at scale, not just, is this review positive? Aspect-based sentiment across billions of tweets. Time series analysis of brand perception. Chatbots, from Eliza to modern conversational agents, the whole dialogue management stack. Multi-turn state, and the alignment problem of making a model helpful, harmless, and honest. And the through line for Lecture 9. Every single application is a case study in deploying NLP, where the input is messy, the output has to be useful, the users are impatient, the data has bias, and the model is going to be wrong sometimes in ways that matter. That's the real-world tension. Loan Through Late built the machinery. L9 shows what happens when the machinery meets an actual customer. 3 takeaways before the quiz. 1. Loan Through V5, the document layer. Cohesion versus coherence. Topic segmentation, entailment, temporal, summarization. Every new layer only exists once you stop looking at one sentence at a time. 2. V6 through V9. Generation, speech in, speech out, vocabulary. NLG pipeline collapsed into LLM prompting. Whisper closed ASR WaveNet plus Tacotron, closed TTS term extraction still ships classical. 3. Lecture 9 is the applications lecture. Machine translation, information retrieval, question answering, sentiment at scale, chatbots. Every one of these leans on layers from late, and every one lives with the mess of real users. Quiz 1. Which pair correctly matches an late task to its canonical citation? A TextTiling to Spark Jones 1972 and BART to Halliday and Hasan 1976. B. Cohesion to Halliday and Hasan 1976 and TTS. Neural vocoder to WaveNet by Van den Oord and collaborators 2016. C. Whisper to Francie and Ananiadu 2000 and RAKE to Radford and collaborators 2022. Or D. SNLI to Hunt and Black 1996 and TimeML to Rose and collaborators 2010. B. Halliday and Hasan 1976 is the classic Cohesion book, and WaveNet 2016 is the raw audio neural vocoder that closed the TTS quality gap. The other options shuffle citations onto the wrong tasks. Quiz 2. Why did Coreference and TTS both look solved after 2019 and 2020, despite being wildly different tasks? A. They were secretly the same problem all along. B. In both cases, big pre-trained neural models absorbed the task as a byproduct. LLMs for Coref, WaveNet, and Tacotron for TTS, instead of task-specific engineering finally cracking it. C. The benchmark test sets got easier. Or D. Both fields hired new researchers. B. Same big pattern of the 2020s. Task-specific pipelines get replaced by one big pre-trained model that happens to be good at the task. Coreference, TTS, Summarization, Named Entity Recognition, all of them over and over. Quiz 3. What does Lecture 9 cover, and how does it relate to Lecture 8? Lecture 9 covers the mathematics of neural networks from scratch. It does not depend on late. Lecture 9 covers NLP applications, MT, IR, QA, sentiment at scale, chatbots, and every one of them stitches L8E10 document, speech, and vocabulary layers into a shipped product. Lecture 9 is a recap of Learn through L8 with no new material. Or Lecture 9 covers only the ethics of AI. L 9 is the applications lecture. Machine translation uses Coreference. Information retrieval uses term extraction. Question answering uses entailment. Sentiment at scale uses summarization. Chatbots use every layer. And every one of these lives with the mess of real users and biased data. Back to the puzzle. If Lecture 8 covered 9 separate layers of structure, how do they fit together inside a real product? Answer: they don't fit together on their own. A product weaves them together. And Lecture 9 walks you through the weaving. Machine translation stitches, information retrieval stitches, question answering stitches, sentiment at scale stitches, chatbot stitch every layer we have. Lecture 8 is finished. Lecture 9 is where NLP finally goes to work. Next time, Lecture 9 opens. NLP applications in the wild. What actually happens when a research lab task becomes something a customer pays for? The messy input, the impatient users, the bias in the training data, and the moments where the model is wrong in ways that matter. Hit subscribe.